I will explain the ingestion layer of our analytics platform, which is responsible for collecting data before it enters the processing, NLP, and dashboard stages. The architecture consists of two parallel ingestion groups: social media fetchers for Blue Sky, Mastodon, and GDAL, and official data producers for ABS and AX datasets. All components are implemented as efficient serverless function running inside Kubernetes. Importantly, these services do not write directly into Elasticsearch. Instead, all collected records first pass through Redis message queues. The social media pipeline contains three main live fetchers, and each fetcher runs using a efficient time trigger, which means collection happens through scheduling pooling intervals instead of public HTTP requests. This design provides stable and predictable harvesting behavior while avoiding duplicate scheduled execution. Each fetcher retrieves data from external APIs, performs lightweight filtering, deduplication, and pushes JSON records into Redis queues. To further reduce duplicate ingestion, the system also implements a Redis-based deduplication mechanism using setNX operation with configurable time-to-leave expiration. The feature intentionally run with only one replica because scaling ingestion is more efficiently controlled through keyword selection, pooling intervals, and pagination size rather than simply adding more pods. Multiple concurrent fetchers could also increase duplicate collection and API rate limiting pressure. After collection, the records move into distributed queue-driven processing pipeline. KEDA scale normalizer service consume the raw queues, standardize the document schema, and forward records into downstream queues. The pipeline then continues into social analyzer service for topic enrichment and sentiment analysis before a single social indexer writes the final documents into Elasticsearch Social Index. Historical backfilling uses a separate isolated processing path through HTTP trigger backfill endpoints and dedicated backfill Redis queues. This separation is important because large historical ingestion workloads should not interfere with live social media collection.
The official data pipeline is architecturally simpler than the social pipeline, and that simplicity is deliberately designed to reflect the nature of the data. The ABS publishes consumer price index, labor force, and net overseas migration data on a public release calendar at fixed frequencies, monthly for consumer price index and labor force, annually for immigration. Each release contains a known bounded number of observations determined by the series being tracked rather than by user activity. This predictability removes the risk of sudden volume spikes and variability in what the API returns between scheduled calls like social media APIs do. As a result, the official producers can be built as simple one-shot functions with no pagination state, streaming consumers, or adaptive concurrency controls. Though ABS releases its data monthly or annual, their past data can be updated on a consistent schedule. For this reason, we designed the ABS producer to be triggered once daily at midnight. Since the volume is bounded and predictable, a single replica running on a fixed interval is both sufficient and correct. The message queue trigger is configured with max retries 0 for the same reason. If a release isn't yet available on a given day, retrying within the same window serves no purpose. The next daily trigger will pick it up once the data is ready. The ASX producer runs on a different schedule, calling every 15 minutes during market hours, but the rationale is the same. ASX equity prices update continuously during trading sessions, so a tighter interval is needed to keep data fresh. The set of track instruments is fixed and small, so each invocation has a known bounded workload of 6 ticker lookups. Both ABS and ASX data are unified under a single Elasticsearch index mapping and ingested through one consumer. Normalization happens in the producers before messages reach the queue, so the consumer stays trivial, and the shared mapping also make cross-source queries straightforward and confidence schema evolution to a single coordination point. Backfilling historical official data takes advantage of the same deterministic bounded structure. Each observation produces a stable document identifier derived from its series, period, and value, which means backfill runs can push historical records through the same production queues without needing a separate isolated infrastructure path. A document the daily producer has already written is simply rejected by Elasticsearch as a duplicate rather than overwritten, making large historical loads safe to run against live queues without any coordination.